Here we go. So here you have your cone and the inverted paraboloid. So in a sense, your z is bounded between the cone square root of x squared plus y squared and on top by 12 minus x squared minus y squared. A better visualization? Here we go. So here we have 12 minus x squared minus y squared, inverted paraboloid, and down here you have your cone z equals to square root of x squared plus y squared. Let me just put that on the board. Okay, perfect. You might say that, hey, you can use double integral to find the volume bounded between these two, the cone and inverted paraboloid. But since we are in triple integral section, let us use triple integrals to find the volume. Okay, so first of all, let us use our cylindrical coordinates. Then we're going to identify the projection or shadow in xy plane. What is this projection? What is this shadow? So here you have, for example, your x. Here you have your y. And as you can see, the projection or the shadow is a circular shape. Circular shape, okay. Just extend this on both sides. This is what you see. So you might say that, hey, by what I see here, theta, or the angle ranges between 0 to 2 pi, but I'm not really clear on r. What is r? R ranges between what values? So first of all, you can say that, hey, z is bounded by, from below you have your cone, so square root of x squared plus y squared, and from top you have your inverted paraboloid, which is 12 minus x squared minus y squared. There you go. Since you're using cylindrical coordinates, our goal is to get rid of x and y. And at the same time, you know that r is equal to square root of x squared plus y squared. All right. So on the left-hand side, your z is bounded by r. And on the right-hand side, it's bounded by 12 minus r squared. This is your z. The boundaries for your z. And as you see, our theta ranges between 0 to 2 pi. Okay, you're good with theta as well. 0 to 2 pi. How about your r? What are the boundaries for r? It's the lower bound, it's the upper bound. So lower bound should be clear to you. Lower bound is just 0. You're interested in finding the upper bound. What is the upper bound? To find the upper bound, what I'm going to do, I'm going to find the intersection between my inverted paraboloid and my cone. How I'm going to do that, I'm going to set, so let me write theta up here, I need a little bit more space, to find r, set, square root of x squared plus y squared equals to 12 minus x squared minus y squared. And since we are in polar coordinates, on the left hand side we have r equals to 12 minus r squared. We want to solve this for r. So r squared plus r minus 12 is equal to 0. It means that you have r minus 3 times r plus 4 equal to 0. It means that your r is equal to 3. So your r is bounded below by 0 and on top by 3. We have all the information that we need. We need to set up our triple integrals. There you go. So you get the triple integral of dv. dv is dz, r, dr, d theta. So your z is bounded below by r, on top by 12 minus r squared. And your r is bounded between 0 to 3, and your theta 0 to 2 pi. Very well, let's calculate the middle integral first. Here I have 0 to 2 pi, I have 0 to 3, and I have 12 minus r squared minus r. Remember, you have another r here, so r, dr, d theta. Let me move this a little bit to the other side so we don't get confused. Okay, let's distribute r here. So you get the integral 0 to 2 pi, 0 to 3, 12r minus r cubed minus r squared, dr, d theta. I have fixed boundaries, so I'm going to separate these two. I get the multiplication of the integral 0 to 2 pi d theta times the integral 0 to 3 of 12r minus r cubed minus r squared d of so this is equal to 2 pi times, here you have 6 r squared minus a fourth r to the fourth minus a third r cubed 0 to 3. I'm not worried about my lower bound 0 because all of these have r in them. So I'm just going to plug in 3. So I get 2 pi. I get 6 times 9 minus 81 over 4 minus, here I have 27, I get 9. If I write it as 27 over 3, then I can factor out that, that's absolutely fine. So I get 2 pi. So if I factor out 9, I get 6 minus 9 fourths minus 10. So far I have 18 pi. 20 minus 9 divided by 4. So here I have 99 pi. Please take your time. Here we